Hello. All right. So there was some confusion on that last problem on the colligative properties reading quiz assignment from last week. And that last problem says, which would a community need more of in order to salt their roads, sodium chloride or calcium chloride? So for this problem, everybody got credit for it regardless of what your answer was, but I did want to take the time to kind of go over the problem so that we can actually come up to a consensus in what the actual correct answer is. So with this in mind, basically the question is asking, in a hypothetical situation, which one's going to require the less amount to salt our roads? So because there's no more information given to us, we can just set up this hypothetical however we want. So let's go ahead and say that we want to go ahead and prepare the roads, and we want to decrease the freezing point by negative 3.00 degrees Celsius. What does that mean? It means that my delta TF should equal negative 3.00 degrees Celsius. In other words, my negative delta TF should equal 3.00 degrees Celsius. All right, so for this, I'm going to look at sodium chloride, and then I'm going to look at calcium chloride to see how I'm going to do this. All right, so how am I going to know this? I'm going to know this by setting up my equation. So I'm going to look at sodium chloride first. For sodium chloride, if I wanted to reduce my freezing point by 3 degrees Celsius, then my I value, just remember we have negative delta TF is equal to I KF times molality. So my I value for NaCl is going to be 2. My Kf is 1.86. And I'm going to figure out what concentration I would need to make this happen. So the concentration of my solution would then have to be the solution to this problem. Okay, so when I solve for molality, I should get 0.806. Okay, and that would be the concentration I would need of sodium chloride in order to reduce my freezing point by 3 degrees Celsius. So how many moles, what does that mean? Well, that means that my molality is equal to 0.806 moles of sodium chloride for every 1 kilogram of solvent. In other words, for every kilogram, I'm going to need 0.806 moles of sodium chloride. So how many grams would that be? So 0.806 moles of sodium chloride. And this should give me 1 mole of sodium chloride is 58.44 grams of sodium chloride. And this should give me 47.1 grams of sodium chloride. So what does this mean? It means that for every kilogram of solvent, I need 47.1 grams of sodium chloride to make this happen. So now let's compare the same scenario to my calcium chloride. So let me change colors here. All right, so for calcium chloride, I'm going to do the same thing. I know my negative delta TF is still 3.00 degrees Celsius. My I value is going to change though, because calcium chloride is going to produce 3 ions in solution. So I have a value of I of 3. My constant remains the same, and I'm solving for molality. So when I solve for molality, I'm going to see that I'm actually going to require a higher concentration here. So my molality is 0.538 moles for my calcium chloride. So what does this mean? This means that to get this concentration, I need 0.538 moles of calcium chloride for every 1 kilogram of solvent in order to reduce my freezing point of the solution by 3 degrees Celsius. So how many would that be in grams? Well, I can just do my dimensional analysis. So I get 40 point, sorry, not 40. Get 110.0 0.98 grams of calcium chloride for every 1 mole of calcium chloride. And this means that I would need 59.7 grams of calcium chloride for every 1 kilogram of solvent in order to have the same effect as my 47.1 grams of sodium chloride. So in this problem, it's asking which one I need more of in order to salt the roads. So which one is more? Well, clearly I would need more calcium chloride. So if I was a municipality and I was trying to figure out the least amount of salt that I would need, I'm going to stick to sodium chloride. It's going to require less amount and it's going to have the same effect than my calcium chloride. I hope this clarifies kind of what I meant by the question and how to solve it and how to go about thinking about the conceptual aspect of these colligative properties between sodium chloride and calcium chloride. If you have any more questions, again, feel free to message me through Canvas and I'll try to address those as best as I can. Hope you guys have a great day. Make good choices.